Okay, dear students, so welcome to this video. In this video, we are going to learn about the third mode of heat transfer, and that is radiation. Conduction we have completed, and convection has nothing. And so we have majorly done everything about convection in the first video itself. Okay, so radiation is a very important topic, and IB gives a great amount of significance to this. And this topic was important for the old syllabus also, and it is equally important for the new syllabus. It has too many things, and no syllabus has been deleted, so we can clearly see that this topic is important. Okay, so what are we going to learn here? So we have learned about the three modes of heat transfer, and two of them we have seen them in details: conduction and a bit of convection. So in this, what is happening is the third mode of heat transfer is radiation. So radiation is actually a part of like electromagnetic wave. So it is that kind of a heat transfer in which there is no direct contact of two bodies which are having different temperature. So they are not in contact with each other at all, and still the warmth can be felt because of the hot bodies. So let us say this is the bodies we're talking about, and it is already very hot and it has attained a very high temperature, which is T. So a couple of things will happen. Point number one is that more like hotter the body, the color could be different. It could be red in color, it could be looking yellow in color, it could be something else. So that is one part that we would be doing about like how the bodies are reacting when a lot of heat is given to them. Now, point number two is when the heat is given and the temperature is already attained as capital T, so it starts emitting a lot of energy. So clearly, you need not to touch the body. You just go near and you just keep your hand very near to the radiator, and you can feel that yeah, some heat is coming to you, although you are not in direct contact with the heater. So it becomes kind of a radiator. So this body is called radiator, you can say, and it is radiating some energy. So more is the temperature, more becomes the radiations. What kind of radiation is it? It is electromagnetic wave which is traveling with the speed of light, and this wave is known as infrared. Infrared is one of the waves in the electromagnetic wave spectrum. So infrared is that radiation because of which we are feeling warmth in the sunlight or in any radiation. When we feel warmth, that is because of infrared. So this is what is happening in the radiation. So the radiation ability of the body or the quality of radiation depends upon many things, and that we are now going to study in details. Okay, so the first thing that we want to discuss today is, let us say there is a body and there is a body, let's say this is a body, and just a moment, please. Okay, let me draw the body here. This is the body. So when a radiation is falling on this, so what are things that happen? Okay, like this is the body. नहीं यार मैंने फर्स्ट तो पहला मैं की सोचा सीगा. Okay, so this is the body, and let's say that some radiation is falling on it. So this is what is incident radiation, and I'm just writing it as I. So let us say that the total energy which is radiate, which is incident on the body, is E. Now, what can happen to this energy? Three things can happen. Number one, it could be getting reflected back. So this is, let's say, ER is the energy which was reflected. Some part of it could be transmitted through the body. If the body is transparent, so it will be moving like this. So this energy can go away. So this, let's say, ET is the total energy which is transmitted, and some part of it will be getting absorbed within the body itself. So we can call it, like, let's say EA is the energy which was absorbed, that is EA. Now, these are the three things. So we define three different factors here. The first factor is reflectivity, reflectivity of, or reflectance or something you can call it. So reflectivity is equally good. So reflectivity, that is R, is the ratio of energy which is reflected to the total energy which was incident. It's just a ratio. Similarly, point number two is the absorptivity. Absorptivity is A, which means it is the ratio of the energy absorbed to the total energy which is incident on it. And point number three is transmittance or transmissivity. Okay, transmittance is a better word by the way. So transmittance is T is equal to the total energy ET divided by E. Transmittance or transmissivity. Okay, something. So that is transmissivity. So reflectivity, absorptivity, and transmissivity. So these are three things that can happen to the body. So bodies are of many different types. Like let us say there is a body which is transparent completely and it is not reflecting at all. So we will say that yeah, ER is zero, like the reflectivity is zero, so R is zero, but A is equal to like something and T is equal to something. So one thing is there, R plus A plus T is equal to 1, because these all are the ratios and the sum of that will be equal to 1. They are all percentages, okay? The total energy is same. So if I say that for certain body reflectivity is zero, let me take the example of a glass. Now glass is completely transparent, so reflectivity is zero, and I will say that A plus T is equal to 1. So clearly, if absorptivity is not zero, then A plus T will be equal to 1. If I say that it is a very good glass, good quality, and it is not even getting heated, even if the heat is flowing through it, even then it is not getting heated up, which is usually not the case by the way. So A will also be taken as zero and transmittivity will become 1. Okay, and accordingly we can create so many things, like we can talk about the mirror. So for the mirror we will say it's a perfect mirror, so reflectivity is equal to 1, neither it is absorbing anything nor it is transmitting anything. So accordingly we can classify many, like the type of body that we're talking about. But in this topic we are going to study black body radiation. Okay, so what is this black body? Now black body is defined in such a way, like this is first of all a hypothetical body. Okay, so black body is defined as a body for which reflectivity is zero as well as transmissivity is zero, so the absorptivity is equal to 1. It means that all of the energy, whatever wavelength and whatever frequency, whatever part of spectrum it is, if that energy is falling on that body, the body absorbs that. So neither reflectivity nor the transmissivity is there, only absorptivity is there. All of the energy is absorbed. That is called a black body, first of all. So this is kind of like perfectly black body, people call it, or like the black body. Okay, now what if it is not a black body? Let's say it is not a black body and it is a gray body. So there is another body which is called gray body. So gray body means like there is no conception of white body, by the way. Don't feel follow like black, gray and white. It's not, there is no white body. Okay, but anyways, gray body means that the body for which the absorptivity is not 1 and it will be reflecting certain part of radiation is getting reflected. So usually this is what is the non-ideal condition, and more practical, and every other body in the world is a gray body. Black body is completely hypothetical concept, and there is actually no such body which can be regarded as a black body. Honestly speaking, like there is no such body, but still some astronomical bodies are assumed to be black body. Sun is assumed to be a black body, which is proved many a times that we can, like 99% of the cases it is a black body. Like in the case of earth, in the case of moon and others, you can assume them to be a black body, but they are not black bodies, but you can assume them to be black body just for the sake of your numericals and the questions that we are going to do. Anyways, so this is what is a gray body. Now, one thing more, and then I would be switching off this video. We will be moving into the next. Now, the thing is, if I say that we are talking about a black body or we are talking about somebody, if energy is getting absorbed, where is this energy going and what is this absorbed energy doing there? So that we have studied earlier. So as the energy is getting absorbed, it is converted into internal energy, which is actually directly proportional to the kinetic energy of the molecules or the atoms or the lattice. So we can say that this energy is definitely going to increase the temperature of the body. So this, I'm just talking about any other body, like this light energy is coming from sun and this body is absorbing some sunlight. Obviously that body has to become hotter, like some glass window is becoming hot. So if they're absorbing energy, they will be getting hot. But the problem is, if I take up this condition that the temperature of the body is not changing, then what? Or if I say that what will happen to this energy, let's say there is a glass which is getting heated up when there is sun there in the day, but at night what is happening? Gradually in the evening or at night, it starts emitting the same amount of energy, and the energy is given back, and the glass is now becoming colder back again. So it is losing the heat and becoming colder back again. It means it is no longer having the same energy. It has emitted that energy, it has radiated that energy. So there is the concept of, sorry for this cleaner. Okay, so there is a concept of emissivity. Now, what is this emissivity? Now, that is the fourth thing that we are doing. First thing is reflectivity, second is absorptivity, third is transmittance, and the fourth one is that this energy goes to this point and it is now emitted back. This is the proper radiation, and this is called emissivity. Emissivity, and we would be learning about it. So such thing is known as emission or the radiation. This is what is the subject matter for us in this topic. We are going to do the black body radiation. So whenever the word radiation comes into picture, whenever the word emission comes into picture, it is this thing that we are talking about. Clearly, more is the absorption, more is the emissivity. So what this emissivity is, we have to move into details for the definition. Let me clear some of the screen now. What is emissivity? Now there are two bodies that we are going to compare with the help of this factor, which is emissivity. Now it is the power radiated by the gray body that you're talking about, divided by the power radiated by black body at temperature T. So both of them are radiating the power at the same temperature. It's kind of a comparison factor in which you can compare the quality of radiation or the ability, the capability of the body to emit the energy back again. Like in 1 second, how much energy can be emitted by the body? Obviously every body will fall to the same temperature after some time. Like for example, things are getting heated up now, but at the night every body will be at a lower temperature, so they have radiated the energy. So everybody is going to radiate energy, but what is the power of emission means that how early and what is the time consumed there. So the power radiated by the gray body divided by the power radiated by the black body, so this ratio is called emissivity of the gray body. Okay, that is E. Now this emissivity is having a value 0 to 1. So E is equal to 1 means that you're talking about perfectly black body, and E is equal to 0, you're talking about the body which is not emitting at all. Such a body does not exist, by the way. So E is never 0, but E is equal to 1 is perfectly black body. By the way, E is never equal to 1 also, practically speaking. So for gray bodies, E is always within this range. Like emissivity, for many things is kind of a very high number, like 95 or 0.97, which can be approximated as 1 also, something like that. Okay, dear students, so in this video we have completed four things. Number one is reflectivity, number two absorptivity, number three is transmittance or transmissivity, and then the fourth one is emissivity. And this is very important for you to understand. And we have done the definition of a black body. So the definition of a black body, like I have not written it, so you can see that from the book, but I have written this in mathematical notation. So a body is called a perfectly black body if it absorbs all of the radiation which is falling on that body. So that has to absorb it. Simple. Okay. And another thing that we completed is E is directly proportional to A, which means a good absorber is always a good emitter. So that, as the notion goes, if you are not absorbing anything, you cannot emit anything. So if I had not learned anything, I will not be able to teach anything. So it's something like that. Okay, dear students. So this is Professor Varun. Thanks for watching. All the best. Bye. See you in the next video. We would be doing the mathematical formulations for the radiation.